Hello everyone, my name is Sanjay Kumar Khadanga and this is my project Credit Card Default Prediction, and those are my team members Vibhuti Bhushan Sahu and Balram Pranibhai. So let's start our project. So first is our content. In this project, we describe about business understanding, next data summary, feature analysis, exploited data analysis, data pre-processing, implementing algorithms, challenges, and last is conclusion. So if I talk about business understanding, in today's world, credit cards have become a lifeline to a lot of people. So banks provide us with credit cards. Now we know the most common issue there is providing this kind of deals are people not being able to pay the bills. These people are what we call the defaulters. Credit card default happens when you have become several delinquent on your credit card payments. Missing credit card payments once or twice does not count as default. A payment default occurs when you fail to pay the minimum amount of due on the credit card for a few consecutive months. In this project, our objective of this project is to predict which customer might default in upcoming months. The research aims at developing a mechanism to predict the credit card default beforehand and to identify the potential customer base that can be offered various credit instruments so as to invite minimum default. Next is our data summary. This is the first 5 rows of our data set, and you can see that this is our default payment next month is our targeted variable. So this is the feature brief summary of our features. This is the first is our amount of credit. That means the bank provides the credit limit to the credit card holder. It includes individual as well as family credit limit score. And next is our gender. Next is education, marital status, if person married or not. Next is age, and next is the column is the history of past payment from April to September. This data set basically provide us the 6 month of data of a person. So and next is the amount of bill statement from April to September. Next is the amount of previous payment from April to September, and next is default payment, that is our targeted variable. So the first insight if we get from our data set is that this is a data set from Taiwan country, and in our data set there are 30,000 rows and 26 columns present, and thankfully there are no missing value, duplicate value and null value present in our data set. And finally, we have a default payment next month variable, which we need to predict for new observations. And this is our targeted variable. And we have 9 categorical variable present in our dataset. This dataset contain only 6 month payment and bill data in our hand. And these are the columns name. Next is we analyze the dependent variable. So this plot, this bar plot shows the distribution of default payment in next month. 0 shows the not default, which is 23,364 out of 30,000, and 1 is the default, this orange color bar. This is the default category, and it the total amount is the 6,636. As we can see from this graph that both classes are not in proportion, and we have imbalanced data set. We need to normalize the data in our next step. So for normalized data, we use the SMOTE operation. SMOTE basically synthetic minority oversampling technique. This oversampling technique is the one of the most commonly used oversampling methods to solve the imbalance problem. It aims to balance classes distribution by randomly increasing minority class, example by replacing them. After performing SMOTE operation, we get this balanced data here. Next is our analysis of sex variable. This left side plot shows the distribution of sex data distribution, and the right side is the sex distribution to the our targeted default payment variable. So 1 is the male, 2 is the female. The number of male credit card holder is less than female. We can clearly see that. and it is evident from this above graph that the number of defaulters have high proportion in males. So next is the analysis of education variable. So here the one is so one means the graduate school, two is the university, three is the high school, and zero is the others, mean the higher education category. From this above graph, from left side plot, we can say that more number of credit card holders are university students, followed by graduate and then high school students. And from the right side of this right side of this plot, this is the relationship between the default variable and the education variable. From this right side plot, we can clearly see that those people who are in other student, means those students who pursue their higher educations, have higher default payment with respect to graduates and university people. Next is our analysis of marriage variable. This here one means married and two means single and three means others. Others means who are not married or single. From the above data, above plot, we analyze that, and from this analysis we can say that more number of credit card holder are single, high defaulter rate when it comes to others. And next is our analysis of age variable. From this above count plot analysis, we can say that we can see more number of credit card holder age are between 26 to 30 years old, and the age above 60 years old rarely use the credit card. Next is our analysis of age variable with respect to default. So from the above bar plot, which shows the relationship between age and defaulter, we can say that those who default are 60 years and older, that maybe they don't use their card frequently. Next is our analysis of limit balance variable, the limit score set by the bank to the credit card holder. So this left side plot is the this plot, the data distribution, density distribution of the variable, and right side plot shows the relationship between the default column. So from the above plot, we analyze the data, and we can say that maximum amount of given credit in dollar is 5,000, followed by 30,000 and 20,000. Next is to checking the correlation between the variables, one or multiple variables, and here we use the heat map, and you can see that in heat map there is various columns are there with respect to their correlated variables. Next is our one hot encoding. We perform the hot encoding. Basically, one hot encoding is a process by which categorical variables are converted into a form that could be provided to machine learning algorithms to do a better job in prediction. Basically, it analyzes the complex categorical variable to a simplistic form. Here we perform one hot encoding on education, marriage, pay September, pay in August, pay in July, pay in June, pay in May, pay in April. And label head, we perform label encoding for sex variable. After this, we get the features in our data set. This below are the total features. Approximately it's 86 variables are present in our data set after we're doing the one hot encoding and the label encoding. Next is our model building. So for model building, we use the four classification techniques. First is our logistic regression technique, and next is random forest classifier. Next is support vector machine classifier, and next is XGBOOST classifier. And we use hyperparameter technique, and for hyperparameter tuning, we use a grid search CV. And we perform first is logistic regression, and after performing logistic regression, after that we do a hyperparameter tuning, and doing a hyperparameter tuning, we get the best parameters, that is C is 0.01, penalty is L2, and based from these parameters we get our results. From this regression model we get the results as below, that is the accuracy is 0.75, precision is 0.69, recall value is 0.79, and F1 score is 0.73 and ROC score is 0.75. Here we can say that recall value is 0.79 and ROC score is 0.75. That not that kind of good, but not that kind of also poor also. So we from next model, that is, sorry, we next is our feature importance. Based on the logistic regression, we have some feature importance differentiate. The first is the pay in July. One means the default in 1 month, the delay in 1 month, the customer delay in 1 month in July month, and next is pay in July and delay in 1 month, pay in September delay in 2 months, pay in June in delay in 1 month. These are the features which are play an important role to default a customer. Next is our random forest modeling classifier. And after performing random forest, we do a hyperparameter tuning. From this hyperparameter tuning, we get the best parameter, that is max depth. With we get the value max depth is 30 and n estimator is 150. And based from these parameters, we perform our model, and from this model, we get the accuracy score. The accuracy of this is 0.83, precision is 0.8, recall is 0.85, F1 score is 0.82, ROC score is 0.83. And in a random forest, we get a good result in recall value, that is 0.85, and ROC score also 0.83. And from this random forest classifier, we get the best features which affect while a customer is doing going to be default or not. First is our limit balance, and next is bill amount in September, pay amount in September, pay amount in August. These are the most important features which play important role. Next is our model is support vector classifier, that is SVC. And after performing this model, we get the best parameters, that is C is 10 and kernel is RBF. And after performing this classifier, we get the best results. Edge accuracy is 0.76, precision is 0.69, recall value is 0.81, F1 score is 0.74, ROC score is 0.77. So here we can get a recall value of a good amount 0.81, but the ROC score is not that kind of good. So we perform the next model, that is the XGBOOST, extreme gradient boosting. And after perform this classifier, we get the best parameters. After while doing the hyperparameter tuning, we get the best parameters, that is the max depth is 15 and minimum child weight is 8. And from this classifier, after performing this classifier model based on these parameters, we get the accuracy score is 0.78, precision score is 0.73, recall is 0.82, F1 is 0.77, and ROC score is 0.79. And the feature importance are the pay in August, that is delay in 1 month, pay in July, that is delay in 1 month, pay in September, that is delay in 2 months, pay in June, that is delay in 1 month. These are the important features which play an important role in the targeted variable. So next is our comparison of all ROC AUC curve of the all model, all 4 model. Here the blue line shows the logistic regression, that is we get the 0.827 score, and in orange line that is the random forest classifier, we get the AUC curve, that AUC score, that is 0.91, and XGB classifier, that is AUC, we get the 0.90, and SBC finally, that is in red line, that is the point is 0.85. So basically ROC AUC curve shows the meaning that the this the area under the ROC curve, that is the AUC, the which model is the higher AUC score, that model will the best suitable model for this problem. And here we can clearly see that the orange line and the green line, that is basically the random forest classifier and the XGB classifier are get the highest AUC score, that is 0.91 and 0.90 respectively. That's why we can say that the random forest classifier and XGB classifier are the best model for this problem. Next is our this is the whole table of while doing the evaluating the models, we combine all the score of the all the model in a single table. Here we can see in logistic regression we get the recall score 0.78, and in SBC that is 0.81, random forest classifier that is 0.85, XGBoost classifier that is 0.85. And here in logistic regression the accuracy score is good, but the recall score is not that kind of good, that but in this problem we get we give the importance to the recall score. That's why we don't use the logistic regression, and that's why we use our best model is XGBoost classifier and random forest classifier. So while doing this project, we have some challenges faced. The first is this is the too much largest data set to handle, and the next is our feature analysis, and we need to remove outliers from the variables, and while doing some feature engineering also, and getting a higher accuracy on the models also. So we need to carefully handle feature which are imbalanced data, and careful tune the hyperparameters, because it is it affects the parameter, the best parameter number. That's why we give a little bit of attention to this. So next is our conclusion. After doing this project, we have came across a sum of points, conclusion points, that is recent 2 months payment status and credit limit are the strongest default predictors. Next is recall is the best accuracy matrices here, because if the algorithm will not detect the defaulters, that will encounter more loss to the bank. And XGBoost provided us the best results, giving us a recall of 85%. That means out of 100 defaulters, 85 will be correctly caught by XGBoost. Next is random forest, which also had a good score as well, but leads to a overfit little bit. And next is the logistic regression, and being a logistic regression is it gets the least accurate with the recall value, that is 0.7, and that is 79%. Higher recall can be achieved if we lower the precision, and if that is acceptable in this problem, then we can surely achieve more recall value. This model can only be served as an aid in decision making instead of replacing human decision, and model can be improved with more data and computational resource. So that's it. We have came to end. So thank you very much for being a patient with me till the end. Thank you very much.